Good day everyone, welcome again to manufacturing session. This will be MGC 1110 session number 29, and for manufacturing it will be session number 8, and it is the last session for manufacturing. Today we will be dealing with milling as part of the machining operation that we haven't dealt with. Remember previously we did drilling and then turning. This will be the last one, milling. And what you are looking at currently is just the basic milling machine, manually operated, but you have few things that you should just keep note of. The feed over here, we have the feed, and then we have the tool holder. This is rotated, and we have a bench. So over here the feed is up down. This up down feed, you can also have, the bench can also achieve that. You can also look into the movement of the bench. The bench can move either in 3D space. So this will be 1, or maybe let me just do this. This will be 1, 2, 3. This will be 1 up down, and number 2 we can say left right, and number 3 we can say in out. Okay, this will be moving in the direction or this direction. This will be moving in this direction or this direction. This handle here will move the tool over here up down. That's what you have there. Okay, let's get in. When we're speaking about milling, it's a machining operation in which work is fed past a rotating tool with multiple cutting edges. So a cutting tool in milling has multiple edges. It's rare to find a tool with only one edge. So it has multiple edges which are capable of touching. So you can have this 1, 2, 3, 4. You can just also do a simple Google check and say for fluid cutter. You will see what a fluid cutter looks like. You have multiple types of cutters that can be used in machining. The axis of tool is rotated perpendicular to the feed. The cutting tool is called milling cutter, and the cutting edges will be called the teeth. So here we will have 4 of them. The machine is called a milling machine, and it uses interrupted cutting. This means that this cuts and it gets out. This also cuts and gets out. This also cuts and get out. Also this one, just like that. So it feeds. The feeding table, as we saw in the previous slide, will be feeding in this direction while this tool is rotated. So the first 1, 2, 3, 4 teeth, or the first tooth, second, third, fourth. If this is your material and the feed of this table, let's change the direction of the feed of that table. So we will just make it like this. I want to have it going there. So you will have the first tooth will cut and get out. The second one will come again, cuts out, third, cuts out, fourth, just like that. As the tool is feeding into the material, because it's rotating, these lines here will be very fine. They'll be very close to each other. You have 2 types of milling, peripheral and face milling. That will be your cutter, the depth of your cut, the feed, work part, cutter, the control. Same here. Feed. The difference is that in the peripheral milling, cutter axis is parallel to the surface being machined. Cutting edge are outside periphery of the cutter. Face milling, cutter axis is perpendicular to the surface being milled or being machined. The cutting edges are on both ends and outside of the periphery of the cutter. So this will be your cutter in peripheral, and this will be your cutting edges, and you hold it on both sides. For the face milling, the teeth will start at the end, and you hold it on this side. This will be your milling. This side will be your milling machine attached, and this over here will be your cut. So this will be your teeth, and mostly they just come out at the end. And within peripheral milling, you can do several types of milling operations. You can do slab milling, slotting, side milling, rudder milling, form milling. Just look into the pictures and see the differences, but it's just these are just terms used to describe this type of operations. This will be your part, types of face milling operations. You will have conventional face milling, this one, partial face milling, this one, end milling, this particular one, profile milling, there you go, pocket milling, there you go again, and surface contour. So here you just want to have a contour along that, you'll follow that. So this is going to be something that you can achieve if you can be able to move your component in 2D. So this will be going in this direction, it will also be going in this direction, it will follow this for this particular example. But if you have a CNC, it can be able to move in all the directions that you need, so you can have complicated surfaces. With manual milling, it's very difficult to have a complicated surface, but otherwise you would use piecewise definition as you got it from mathematics, something like this, going up, and let's say it's in 3D, you're probably gonna do 1, 2, let's do it on an isometric, 1, 2, 3, then again 1, 2, 3. So this will be, if it's again, let's do it for the last time, 1, 2, 3. So that will be a line in 3D starting from here going all the way up. And if this operation is done by a CNC with much more precise controllers, the length of the sides can be very small, so small that you might not be able to see them, so you just see a smooth surface there. But basically what is happening is that they would have been broken down, now come again, break it down, and break it down, just like that. That will be how it will be moving. The tool will be moving sequentially and systematically in order to get the curve that you need. So let's say you can even achieve this, to move like that, and over here to change direction, just like that. Face milling. So with face milling, it's when you cutting the top surface of your component. You can use whatever tool that you need depending on the size of your component. So for bigger sizes, you might need multiple teeth cutting tool. This one uses indexable inserts. These are the inserts. You can replace them. If they get damaged, it's easier to replace those and cheaper, as opposed to throwing the whole tool out. That is the 6 teeth tool features. On the indexable tool features, you have few things that you need to be on the lookout for: the rake angle, insert cutting edge, and the lead angle, the wedge axial rake angle. That was a radial, this one, along this direction, and this one is the rake angle. So you are just comparing it here now. There are a few YouTube videos that you can go watch, and you can, even if you have time, you can go watch many more. There are 2 types of milling machines, and they perform the 2 types of milling operations that we spoke about: knee and column milling machines. The column milling machine will be this one, where you can find face milling, and this one, knee. On this one you can find peripheral milling operation. A knee machine, you can also associate it with horizontal milling, and the column milling, we can associate it with vertical milling. We can now speak about machining centers. So we will be talking about milling center, or a turning center, or a drilling center. But basically these are the big machines that you will find that can achieve all the operations at one go, and mostly you find them in a form of CNC. So the CNC machine is the numerically controlled machine, so it's precise and automated. So a machine center can be a huge machine that takes all the operations and it performs them systematically and automatically without any human intervention. It has more access. Most of the operations can be milling and drilling, but even turning can be included. Several access, automatic tool changing, pallet shuttles, and automatic part positioning. The typical one, and you can just appreciate the size. Also, you can appreciate the kind of products that can come from this machine and the rate of production as well. Here is for turning. You can have them both combined. It will be a huge powerhouse. They are automated, so the machine centers are automated for machining operations. We have over here general configuration of a turning center. Can position a cylindrical work part at a specific angle, so a rotating cutting tool. Can machine features onto outside surfaces of a part. Conventional turning center cannot stop work part at a defined angular position and does not include rotating tool spindles. Operations that you can find in a machining center. Okay, so this will be the output component and this will be the operations, but they don't end here. You'll do turning, milling, drilling, cut off. You can even have a handling of this component out of the machine. Engineering analysis, peripheral and face milling operations. So we are going to look at the peripheral and face milling operations. We will describe them. First one that you're looking at is called the peripheral milling, and this will be your work part, and this will be the jaw side. So your jaw will be holding your component over here, and this will be your cutting tool, and it will be rotating in this direction. And this is stationary. This will be feeding. Otherwise, here we've represented it just like that, but that was because we wanted to indicate to you this position and this position. So I'm going to stick to what we have presented you with. But remember, most milling machines, the tool is stationary, the part is being fed by the table. Remember, the tool is stationary, but the part is fed in by the table. Linear feeding, it's going to have a linear feeding. Okay, now you need to consider a few things. The operation will start when this tool touches the component over there, and it will end when the tool is done over here. Okay, now let's say you want to cut this depth and you need to define few parameters. So you will start cutting from, the machine will start cutting from this when this part touches. Therefore, we need to track, this is the center of the machine, so we need to track exactly from what point. We need to track the position of the center when the machine starts cutting up until the machine stops and finishes, not stops but finishes cutting. So it will be from here till this point, and that distance you can calculate it with L from the part. A is called the approach. The approach is this distance here. For this particular machine, in order for you to get that distance, think of it this way. You have this, we told you that you need to cut D, that means in this direction going down. This will be the bottom surface, this will be D. This will be D. This will be the diameter all the way down, and this will also be the diameter. And then you have this line going in. You can now work this out. So diameter, or radius rather, another R, radius, another radius, then you have a D there. You have a 90-degree angle there. So you can be able to work out this length, which is your approach. The machine, the approach, what it means is that during that phase, the machine will not be fully engaged, but it will be cutting. Okay, that is with a slab or a peripheral milling. Then we have here face milling. This one is face milling. This one is face milling. We are cutting from the top. Okay, with this one we are cutting from the top. The axis of we are looking at it from we are looking at this machine from the top now. So over here, if I could draw it on the side view, it would look like this. For the peripheral milling, it will look like this. Cutting tool, your cutting tool is rotating around this axis, and this would have been your part being fed to the cutting tool. So almost just a little bit bigger. So it's going into the page, and this cutting tool is rotating around this axis. With this one, it's the top view. The feeding of the top is this direction, and this component is rotating around this direction. If we were to look at it from the side, we would see a cutting tool rotating around this axis, and the face of the component will be going just like this, but being cut over there, going in this direction. Okay, let's just look into a few things. The approach for the two machines is different. Over here, you will have the approach if you're starting from the outside, but for this particular one, if you're on the center there, if you start to cut on the center with this on this position, that means your approach will be D, or not D, but it will be this distance A, which is diameter divided by 2. In the case that you are on the side, example, if you are just cutting on the side, the approach will also just look like that. Remember, if you are cutting on the side, you will have something like this. Let's assume this is your bigger component, so it will be something just like we had with peripheral, and then you move out. And for this type of work, all 4 teeth must get out of the material, or all the teeth must get out of the material. Then you are done with the cutting operation. And when you're getting out on the other side, you have a dimension O. So O represent over dimension. So you need, after you are done cutting, you just need to move out and to complete that cut successfully. This is with the face milling, but with this one, you move. Once you are there, you have completed your cut to get out. The thing is, if you get out, if you just move this tool over here, you will not touch this material anymore because it's a radius like that. For this one, you will still be touching with the back at the back. So let's say when you're entering, you'll be touching with this tooth, and when you're getting out, this tooth will be touching at the back. Over here is the same thing, because it cuts not on the side but at the bottom. So this one cuts at the bottom, its cutting edge is at the bottom. it cuts around here while your part is moving in this direction. For that, the top machine, it cuts with the tip, but the movement of this component, once this point has been reached, it will not touch the material anymore. However, with this one, your cutting tool will remain in contact up until you get out of the material altogether with this overhand. There are two types of milling or cutting styles. This will take into consideration the rotational speed of the tool and the feeding direction, or rotational direction and the feeding direction. We call it up milling. The feeding is in the opposite direction as the rotational direction. At the point, let's call it at the point, the feeding speed or the feeding direction is in the opposite direction at the point of contact with the rotational cutting tool. There you go. So over here, if you were to give us a velocity over here with that rotation, your velocity would be going this direction, while your feeding will be going in this direction. The velocity of the feeding is in that direction. And keeping the rotation in the same direction, down milling, the rotational speed at the point of contact is in the same direction as the feed of the component. There, the speed will be going this direction. These two are the same. The equations that you need to be aware of, and be able to use, you have few of them. Feed rate, given like that. Feed, you know, we've dealt with that. For feed, in this case, we're dealing with a chip load, so millimeter per tooth. Now we are dealing with strange units now. NT, number of teeth. FR, feed rate, we've dealt with that. A will be the approach. Know how to calculate the approach for the two different setups. This will be the equations that you need to use for milling. These two, they represent two equations that you need to consider for peripheral. This for face milling. Speed will be the same. Maybe I should just note it down for you. The speed will be N is equals to velocity over pi d, as we've been doing that. And then material removal rate is given with this equation. Everything is derived already. You know how to calculate them if not given. D, depth. F will be feeding rate or feed rate. Then you have here these two equations here: peripheral, face milling, the approach for face milling, and over here you have the approach for peripheral milling. Look into your textbook, know how to calculate them, understand what does a unit mean on a symbol or on a calculation. Sometimes you're gonna find a unit like this, so that you need to understand the chip feed, give it here as a chip load, and then we calculate it as millimeter per tooth. Okay, how much does one tooth take in terms of millimeter at that feed rate? Those are the equations. Milling exercise number 1, you can do this, and we are going to discuss this in the discussion session. Milling exercise number 2, we will be discussing this as well in the discussion session for this week.